Yes, so let's start today class. So today I'm going to recap few items which we have already completed. So like we have completed landing table. So as we know that this was the starting point of Informatica MDM where we push the data, and we know that for multiple sources we can create a single landing table, or we can create a multiple landing table for each sources. It depends on our data volume from the source. This is how to implement CDC using landing table. So this option I want to show you. That time we have not covered yet. So let's come to a schema, and if you come to landing table, you can click on any landing table. So here we get option of contain full data set. Okay. So this option basically helps us to apply the delta or chain data capture on the landing table. So suppose we have one ETL which is loading data from external source to our landing table, and in between that you want to apply some CDC logic. So you can apply that CDC logic in your ETL also, or if you don't want to apply CDC logic in ETL, so MDM can also handle it. For that we have this option. So if we are checking this contain full data set, what it will do, it will copy all the data from source to landing table. So it will not identify data. It basically it will copy all the data, copy and paste. Okay. And if we are disabling it, so what it will do, it will copy only delta data. So delta data will be identified on what condition. So for that, as we know that in every landing table, there is a default column that is called last update date. So basically this is a system column which is added by Informatica MDM. So the use of this column is to identify delta. So if we are unchecking it, if we are unchecking this and we are loading data from source to landing table, so what it will do, it will compare the last update date of the data, and accordingly it will identify the delta record, and that delta record will only be loaded in landing table. So this is the use of contain full data set. Okay. So landing part already finished. Let's come to a staging table. So in a staging table, as we know that it is a subset of base subject table. First we create the base subject table, and we select few columns on the base subject table, whatever needed for the respective stage table. So a stage table is a subset of base subject table, and PKSRC object will be the primary key for every staging table. Okay. This we have already covered that for every source we have the separate stage table. We don't have option to create a single stage table for the multiple source. So this already we covered. For creating a stage table, these are the steps. We need to define source system, and then we need to create the base subject table, and accordingly we can create a stage table. These are the child tables of a stage table, which we already covered in previous classes. This reject table, it will hold the rejected data. This PRL table, it will be applicable once we apply the delta detection. This raw table, it will apply once we configure the audit trial. And there is a called OPL table that is also called online processing. This is same like PRL previous landing. So this is used for the batch, and this is used for the online processing. So this we don't use in the general cases. Mostly we use PRL because PRL is applicable for the batch job. Now let's come to a stage process. What is a stage process? So once we are loading data from landing table to a stage table, so that process is called a stage process. That means what the mapping we create, what the mapping job we execute, that is called the stage process. Okay. So that part already we covered. Here we have some region of rejection. Yesterday in previous classes we saw that record was rejecting due to last update date null and all. So here are the region of rejections we have. So if last update date is null, then it will reject. If last update is future date, again it will reject. If last update date is less than 1900, then again the data from landing table to a stage table it will reject. So these points you have to remember, because they ask mostly in the interview like what are the different region of rejections. So on the last update date we have three condition: null, future date, and less than 1900. Okay. And on the PKSRC object, as we know that this is a primary key, so it cannot hold a null value. So if you are getting null value, then again rejection will happen. And if PKSRC object, suppose in some cases we have the same value, then what will happen? Suppose we are populating the customer ID in the PKSRC object. So it will see the max last update date. So suppose yesterday we had the same last updated because you created the record yesterday on the same day. But because you have the two customer ID and one is came on the 1st July and other came on 10th July. So both having the same PKSRC object. So 10th July record will be taken care by this MDM. So 10th July record will be loaded and other rest of the record will be rejected. So max value of last updated record will be loaded and other will be rejected due to the duplicate value of PKSRC object. And the other condition is that in this case, suppose the last update date is also same. Then we saw yesterday it will take the max value of SRC row ID, and that max value of SRC row ID is basically the first record in the sequence. So yesterday we saw this scenario was there in yesterday case. So if PKSRC also same, if last updated also same, then we need to look for the SRC row ID, and that value will be populated by Informatica. So for every stage table, if you see, let's come to database. Here we don't have, I truncated this record. So let's see the SRC row ID. Yeah. So here you can see the value of SRC row ID, which will be generated automatically by Informatica MDM. So the max value of this will be taken and the rest will be rejected. So these are the different region of rejections. And delta detection already we covered yesterday. Audit trail already we covered on the stage process. Now let's come to today agenda. So today we are going to focus on the clinch functions. Okay. So let's come to clinch function part. So in the model section, you can see here clinch functions. Okay. So these clinch functions, whatever we have here, you can see this all is available in the mapping section here. So once we create the mapping, yesterday in the previous classes we saw. So here we can apply these all the clinch functions. How? Just we can click on this function and we can see all the options. So these all options are available in the clinch section function here. So for understanding, just we will come here and we will try to understand all clinch function one by one. And if you want to add any clinch function, you can add here. So we will add here. So let's try to understand first. So let's come here. Here the good thing is that here you can do the testing of the clinch function without using that clinch function in mapping. So here you can do the testing, like this is uppercase. So these string functions, as we know that in the SQL also in different databases also we have the string functions. In Java also we have a string function. In C also we have a string functions, right? So in every language you will have the string functions, and these string functions mostly will be same, like init cap, title case, stream, uppercase, right? This will mostly be same. And if we have a doubt, then here we can see the description. So see, for the example, this uppercase, what it is doing, here it is taking function inputs. So this will take one input, the string to convert, what a string you want to convert in uppercase. So this will be one input, and here we will have one output. So output will convert incoming string from in a small case to uppercase. If you want to test this, just you can come here and here you can pass. So here we can pass, suppose Ram in a small case, and let's test it. So see here we are getting in uppercase, right? Same like that, we know trim what it will do. Here description you can get, removes the white spaces at the beginning and the end of the point input. So these all are very similar to SQL and others, so I'm not going to take this. Some of the functions I will take which are not used other places, so that will be learning for us. So these all are similar, no need to spend time on this. A split and reverse. So what it will do, suppose you are writing Siva Kumar. So what it will do, it will do Kumar Siva, just it will reverse. Okay. From here also you can see the things they have written clearly. Divide the input string into two parts and reverse their order. That's it. Right part, it will do padding in right. Here we have a regular expression. Let's try to see it. So what it is saying, extract a match in regular expression. So here we need how many input? One string which needs to be converted. We need one input. We need to write some expression, and in the group we can write some default value. If we are not finding any match, then it will pass the default value. In the output we are going to pass the output. So here let's come in test. Here we can see we need to pass 3 input. Okay, so let's take a string as 1 2 3 4 5 6 7 8 9. And suppose in expression, I want to give some expression like that, regular expression. Suppose we have input like that, and we want to take only first five character or last five character or character starting from second to third, something like that. So those kind of regular, same like sub str, those things you can do. So just we can do \d and just copy this basically. And let's test it. So here we are getting 1, 2, 3, 4, 5. So starting from 1, let's start from 3 and let's see the result. Why we are getting this? Starting from 3. What is this? Again, we are getting 1, 2, 3, 4, 5. Why? Let's come here in description. In description, we don't have much for this. In the extract and match in regular expression. The regular expression to use and this. So here, do I have other example? \d 1, 2, 5. See, this one not working, so basically we have to put the, just a minute. How to pause this recording? Just resuming. Yeah, so here in regular expression, let's come here. So this is saying that it extracts the record on the basis of some match. So here, if we are passing like that, an error occurred, what is the problem? So here we need to pass the, let's remove this. Let me copy this. Okay, so here basically it is taking the first 5 character. If I am giving like first 4 character, it is taking a note. Let's see. See, so it is starting from 1. It is just we can manage the number of characters. If I want to take first 2 characters, so it will take first 2 characters. Like that, in Informatica website, we have other complex regular expressions logic also. If we need it, we can just copy and paste that expression, and it will work on that. This regular expression sometimes we use in our SQL also, so same like that. Here we have a padding, so adds a space at the beginning and end. Lowercase is very similar, opposite to uppercase. Left pad, this I am removing. Format, here we have one a new one. So in format, it's the clearly written, replaced with the next character in the string to format. Also used to entry any literal character that follows, for example, this. So what it will do, suppose here we have our mobile number like 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, something like that. So here in the text, here you can write question mark. For each character, it will work like question mark. So suppose I want to put my mobile number like question mark, 5 character, then comma, then 2 character, then 3 character, like that. So whatever format you will give, just it will show in output. Here, if you want to put some bracket, so here you can put the bracket. So if you are putting the bracket, we can see like that. Okay. So this format is similar to regular expression. Here you can just use a question mark for each character, and you can write a pattern accordingly. It will show like that. Default value, as we know that if something will not match, same like NVL we have in SQL, right? If incoming is null, then it will give some default value. Same like that here, it will give some default value. Concatenate is a little important here. Important is in the region. Here we can see in concatenate, here we have only 6 input. So with the help of the concatenate function, we can concatenate these 6 input and we can generate one output. So suppose we have a kind of 15 input columns which needs to be concatenated and combined into a single output. Then what we will do? Because this function is only can combine up to 6 input function. Okay. So what we are going to do? So in that case, if more than 6, what we will do? We will combine these 6 input and will pass to output, and this output we can again combine as an input for other concatenate function. Okay, and after concatenating again output of this 6 to 1, again you can use the concatenation. So you can do the nesting of concatenation. Admit. Yeah. And hello.
Hi, Abhishek. Good morning.
Yeah, hi, Raju.
I'm audible?
Yeah, you are audible.
Okay, thanks. Thanks for inviting me this meeting. And since this is a first class, so
Thank you very
you
much.
can
So
provide the
this
training.
class
Later
is
we can.
already in between. So just you can have a look on the training, and after the training we can connect. We can have more questions answer.
Okay, thank you.
Yeah, thank you very much. So Ashish, this concatenation, let's try to see in the mapping. So here we
Can we
had
create any extra port also?
extra port means
Extra attribute in between landing to staging?
okay. So extra port, if you want to add, like in the stage, if you want to add extra port which are not available here, that we cannot do. Yeah, that conversion we can do, the data transformation and all we can do, but addition of port we cannot do here in means MDM mapping. Okay, so just I'm removing this delete object, and let's try to take the concatenate function to combine the input. So yesterday we saw that we just passed this customer ID directly to PKSRC object, and in some cases if customer ID is same, then due to duplication that record will be rejected. So now what we want, let's take customer ID, customer name, and address also. Let's combine these 3 columns, and then we pass the output to the PKSRC object. So what it will do, it will combine that 3 columns in the source, and then the output will be passed to the target.
Sorry for interrupt. Can I ask the one question?
Yeah.
If you don't mind. So you just shown to us you are mapping 3 columns, right? Customer ID, customer name and address, and you are mapped another column S underscore ETWS cost to PKY. This is you are combining the primary key you are making or something, but I understand what is exactly.
So if you know concatenate function in SQL or in ETL, just it will combine, right?
Okay.
So we are not giving any kind of what we say means character to combine in between. Like if you are combining A and B, so you can give pipeline also, A pipeline B, then
Got
again
it.
pipeline C, something
So
like that. So
okay.
that pipeline we are not giving. So what it will do, it will just blindly combine without giving any additional character between the two inputs. Okay, na?
So
yeah.
what is the benefit? What is the means goal of this combine? What we are going to achieve for that? Exactly.
Yeah, so actually you have not attended the previous classes. So what we are going to do, earlier we used to pass this customer ID directly to PKSRC object. And
okay.
PKSRC object is basically a primary key for this table, okay?
Okay.
So in some cases, if we are getting the same PKSRC object for the multiple record, and this is a primary key, so other record will be rejected. As we know that primary key cannot hold the duplicate record.
Got it. Got it. Got
So
it.
for solving that purpose, we are combining other
Got
columns so that we can avoid
Make a
the
unique
single
record
position.
for the.
Correct. For
Got
the
it,
primary key.
got it. Thanks. Thank you so much.
Yeah, thank you. So let's see the result of this so that we can understand the concatenation in Informatica MDM. So basically, what we did transformation and all we do very rarely in Informatica MDM because we have very limited feature and it's very tough to do here. So these all things in the real-time project we do in the ETL. So in ETL, once we dump data in landing table, we will see that all the cleansing and all the business logic will be applied itself. The data which we get in landing. But in some cases, if we see that logic we cannot apply before landing, so in that case, we can apply few of the logic here. But in most of the cases, if you see in the real-time project, this mapping will be very straightforward, very simple. Just make sure that this primary key column should be not have duplicates. For that purpose, we do some logic. Otherwise, mostly it will be one-to-one. So let's save it and let's come to batch viewer for running. And as we know that, what was the mapping name? The mapping name is EDW cust. So that record is coming from EDW source. Let's come to batch viewer. And we have to come EDW here. Batch name is EDW. Name now is stage process. And let's run it. So let's see that delta detection is still enabled or not. So for that, we need to come to base subject, then base subject table, then a stage table, then here. So this delta detection is still enabled, so we have to disable. So Ashish, yesterday we saw that it was failing, and I did lots of research on that. So I found that there is no issue in our logic. The issue was there with their product. Okay, so they have released Informatica have released some hot fix for that. So I need to apply that hotfix, and for that I need to request separately for getting that hotfix as part of the product. And once we apply that hotfix, then that issue will be resolved. So basically, that is a product bug. It's not our logic or our kind of understanding issue. Okay, that is a product bug. So for that, we need to apply the hotfix from the product side. Okay. So yesterday we understood the concept. So just I am disabling this, because after enabling we are getting the mapping failure, although everything is working fine in backend, but mapping was failing. So just I'm disabling that, and I'm coming to batch viewer for running again to understand the concatenate function. So here we can see we have 6 record in source and 6 got inserted. See, this time we got all record inserted, no rejection, because if we see our record in a stage table here, so we have 6 record. Now let's see the PKSRC object. This is interesting. So see here, now earlier customer ID was coming, now customer ID, name and address all got combined. So now we got the unique record. So now no record is rejecting. Huh?
Oh,
So
okay.
yeah.
So this is a combination of the ID, address, and right. So we have getting the unique record.
Correct. Whatever logic we will apply here in combination, so it will just combine and it will give the output, and that output will pass to the here.
So in this scenario, so we have in flat file or in source table. So we, say for example, multiple duplicate. They can we can achieve this approach to redundancy, data redundancy, and concurrent, and can reduce the duplicate record, right?
Right. Correct.
Got it.
Basically, in real-time project, what we do for avoiding such things, we generate some ID in landing table itself. You know, so landing table is a starting point of Informatica MDM. So once we get data in flat file, CSV, XML, whatever source, so we use the ETL tool to read data from all those sources, and we do generate some ID, unique ID for each record, so that ID we can directly pass to PKSRC object.
Got it.
So this handling you can do in your ETL also before pushing data in landing in this table. And if you have not handled that, then you can do handling here also. But in most of the cases in real-time project, you will see this handling will be done outside of MDM. So we will have some unique ID, and that ID will be unique for all the record, and that can easily be passed to the PKSRC.
Okay, got it.
So let's come to clean functions. So most of the clean functions in a string functions we saw, it was similar to our other clean functions, same in SQL, Java, or other languages. Here compress white space, it will just compress white space before and after. So this is all about a string function. Is nothing special here. All are same. We have few string function, few functions here, which you need to learn as part of this tool. So I will focus more on that. So that is we have some few good function in miscellaneous function. So here, if you are coming here, we have now. Now is same like we have sysdate in Oracle and other databases, right? So it will give the output the system date. So now it will give the output of system date. Same like that for example, if you want to do testing here, and here we cannot pass anything, just we can apply that function. Here we can see the system date. So why it is showing 2016? Because we have backdated our server just for applying the license file, and whatever server date we have, server date time, the same it is fetching. So this is same like now sysdate. And here we have one good function that is called read database. This is very useful and this is unique kind of, which you will not basically get in ETL and other places. So this function we mostly use in our Informatica MDM mapping. So what is this function? So for understanding that, if you have worked in any ETL tool, you know the concept of lookup, right?
Yes.
So same like that, it works on the same concept. So suppose you have one table, employee table, and we have other child table, that is department table. And in employee table, you have employee name, employee ID, and department ID. And if you want to fetch the department name of the employee, what we do, if we don't have ETL, we write some SQL, right? In SQL, we can do left outer join or inner join on the basis of department ID, and then we take the department name. That's what we do. So same thing here also we do, but we do in a different way. The same logic is applied here also in a different way. How we will do? So here we have these much inputs. These are inputs and these are outputs. Output is nothing but once we do lookup and once we get the output in the lookup, like if you are doing lookup on department ID and if we are getting a department name, so department name will be in output and department ID will be input, because we are passing department ID here and we are getting department name. Okay. So here let's see, we have many columns which we can pass in the input. It depends on our requirement, and we have many columns which we can take as output. So first here we need to pass the table name. Okay. So for that, let's create some tables to do the POC. So here, let's come to database. So we have a landing table for the customer here. And in the landing table, here we have address. Okay, here we have customer name, customer ID. So let's create a full name, one table which is contains the full name of the customer. So it will just do lookup on this customer name column, and it will fetch the full name. Okay. So just for testing, I'm creating one test table, and that table, landing table, we can come here. How to create landing table? Again, we can recap. Come here in landing table, right click, add item. So this landing table name always we start with L for easy understanding.
Okay.
And this I am giving full name, full name, customer full name. So suppose this is our lookup table, which will contain the customer full name. And this will be given by Informatica itself, C underscore for better naming convention. Let's click OK. And we have got the table. And let's add some column here in table. So we should have customer name like it was available in parent table, above table, so that we can do lookup on the basis of that. And then we can have the full customer name. Full customer. Okay. Now let's save it. Let's take the simple example so that we can understand the concept. So we have these two columns. Now let's come in backend and let's see if we have we got the table in here. We need to refresh here. Right click and refresh. And here, if we come, then here is our landing tables. It will be CL. Here we got our landing table. Okay. So we don't have any data. Let's add some test data. In the last update date, let's give the now and customer name. Let's take a Siva because Siva record was there in our test record. So let's take Siva Kumar as a full name, and let's take one more example now. And here we can take Ravi. Ravi was also there, and here we take Ravi single. Okay, and let's take one more record which was not there in our lookup table. So I can take other record, suppose Disha, D-I-S-H-A, and for Disha, let's take Disha C. So for Disha, we don't have matching record, so we should not get anything. So let's take this example. So we will do lookup on the basis of this column, and we will try to take output this. So we'll see how we can achieve this. So we have created this landing table. Now we have to come to mapping. Let's come to mapping. And this one I am deleting for time being to okay, let's keep this. Let's keep it here. And this time we have to take the function, this one, miscellaneous function and read database. Okay. So we came to read database, and let's right click. And here we need to pass the table name. Okay. So table name we have to pass as a constant. Here you can see we have one constant. Okay. Constant, if you want to pass any constant, we can click on this key. And we need a table name. Table name we can copy from here or not. Edit. Yeah, we can just copy from here. So this is our physical table name. Okay, we have to refer this table name. So I'm taking this. Okay. So this table name we need to pass to table name field. Okay. So this table name we pass in table name lookup column. So on what column we want to do the lookup? We want to do the lookup on customer name, right? So let's pass to one more field name. First name, okay. So it will understand that the lookup column name is cust name. So we pass the lookup column name. Now it is asking lookup data. So we given the table. Let's see, come here for confusion. Just a minute, diagram. So here we given lookup column 1. It will do lookup on the basis of that. Lookup data. What data we want to do the lookup? So lookup data will come from here, right? Lookup data we are passing from here. So this lookup data will be passed, and it will go to this table, and it will do lookup on the basis of customer name. And these are the return columns. Okay. So this return column, I can remove this customer name column from here. And for easy understanding, this mapping let's remove, and let's pass this return column 1. So return column 1 also we need to pass here what column we want to return. So we have here we can see we have many columns, right, in this table. So which column we want to return, we have to specify. So we want to return full customer name. So here let's pass the full customer name which we want to return. Okay. Other options, if you want to specify, it's okay. Otherwise, you can keep as it is. And let's take the result of this return column in the customer name. Okay? Yeah, for in the example. And let's save it. And let's try to see if this is working or not. So for that, what we can do, if we are coming to test here, and if I am passing, suppose customer ID as this, and customer as a customer name, I need to test. If I am passing Siva, so let's see. This one, it is combining customer ID, customer name, that is fine. And see, here we are getting customer name as Siva Kumar, right? If I pass Disha here, Disha was also there as a test record. I should not get anything. Disha, see,
got it.
Okay. So Disha here, I am passing hard coding that record. Okay.
Yes.
Here I am hard coding for testing. But once we will run our job, So we know that in our landing table, we don't have any record for DISA. So we will see that in a stage table for DISA, we will get null value. But here, if I'm passing DISA, we have the record for DISA, so we are getting here.
This are same.
DISA, right? Here, if you are passing Raju, suppose. So we don't have Raju, right? So we should not get anything. See, we are getting null.
Okay.
So whatever logic you will define in our mapping, whatever here mapping, that testing you can do here in the test window for confirmation that your logic is working or not, right? So here we saw that our logic is working fine and we saved it. Now let's run the batch. How to run this batch? For that, you have to come to batch viewer. And now you come to EDW cast. This is your batch. This is your mapping name basically. And let's run it. It's still running. Hand signal means running. So let's refresh this. We got completed. All 6 record got inserted. So we know that the target here in mapping, whatever target we have, let's come to mapping here. This target is a stage table, and this is always a truncate load by default. Okay, so it will always be truncate load. So nothing to worry that what record was there previously, it got overwrite or not. So nothing to worry. It will always truncate and load. Okay, by default by system. So let's come to a stage table. Let's come to a stage table. It's EDW stage, this table. And let's see the data. So this column is combining due to our logic of concatenation. And let's see the cust name column. So here you can see, where is the cust name? Customer name. Achha, cust name we have passed to the customer name. Okay. So for Siva, we got some value Siva Kumar because Siva was there, Ravi was there, and this Siva also was there. So we had 2 Siva in our landing table. Let me take plus. Okay, here we have output. And if you want to compare this output working fine or not, let's come to our landing table, which is a main source. Where is CL cust? Okay, here you can see. So for Raj, we don't have any matching. So for 100, we should have null. So for 100, if you will see, where it went, minimize a lot. Okay. Now we can see for 100, where is 100 record? Sorry, okay, 100. Why we are not getting 100? Because this is from CRM source, okay? So we are talking for the EDW source. We have applied logic filter here. In this mapping, we have applied filter here, source system equal to EDW. So it will only pick the source system equal to EDW record, not the CRM record. This was the CRM record. So we will not discuss this, okay? So for 500 and Siva, let's see what we got for 500. For 500, we had Siva, we got the Siva Kumar. That is working fine. For 600, we had Ram. For 600, we had Ram, and we don't have Ram value in the lookup table, so we got null. For 700, we had Naveen. We don't have Naveen in the lookup, we got null. For 200, again, we had Ravi, so we got Ravi single. For 300, we had Siva, we got Siva Kumar, right? So this is working fine. So this is working same like lookup concept in Informatica Power Center or left outer inner join in the SQL. Okay. The way of implementation is a little different, but the concept is same.
So one question here. So say for example, in Informatica Power Center, we have a concept called connected and unconnected lookup. So
right.
say.
So in Power Center, we have connect lookup and what we say unconnect lookup. So unconnect lookup you can call at the many places in the port, right? So that helps as works as a function. Like how we call the function. So the same way we can call the unconnected lookup wherever you want. So here we don't have that concept.
Oh, okay. This way you want to understand.
Yeah.
So in unconnected concept is not in covered.
Not there. Not here. Is here we have very limitations of the transformation between.
Got it.
Okay, we have very limitations. We have only few things available because in real-time project, if you see, these all things will be taken care in ETL part. Okay.
Okay, got it.
So just for understanding, I'm showing that. So here we have lots of limitation in the transformation section. So we saw concatenate, we saw format, we saw the read database. Now again, let's come to clinch function. And
Abhishek, just
yeah,
one question.
yes, yes.
Can you open that mapping?
Yeah, let me go to that mapping. Yeah.
Yeah, so for more than six column concatenation, so after concatenation, we have to again apply one concatenation and we have to pass
Correct.
that
You
string
got
to
it.
that.
Yeah. So suppose we have 20 input fields which we have to concatenate, then we have to pass the output, right? So what we will do, we will take first six column up to string 6. We will take the output. Again, we will come here. Again, we will come to concatenate here. Okay. And I will take concatenate. What I will do in that case, I will take the result of this and I will pass here first. Okay. And again, I will take the remaining 5 columns from the source. Okay. Then I will take the result of this in other concatenate. Like that, you have to do the nesting of the concatenate and you can achieve that.
And if we want to pass something like pipe delimiter, so in that case, we have to create one constant pipe, and
Correct.
that
You are correct.
we,
You are
okay.
correct. So if you want to pass some delimiter in between the character, so for that, like suppose here we pass it directly, right? Let me delete this. And here in this case, you want to pass some pipe delimiter. So what we need to do here, let's delete this, and here you have to take constant, and here you can take the pipe delimiter. So, okay, and that pipe delimiter you can pass in the second port, and again you can take the customer name, something like that. Okay, again this pipe delimiter. Here we will take, okay, no need to take this. I think we can use this side and pass here. Same value we are going to take this. Okay, sorry, this one customer name is fine. Now we can pass here, and again we take the address in the next column, right? So like that we can do. Like that we can do assist. We can take one constant
Okay.
and we can pass that constant here. For example, we can do this testing also if you want. No need to run the mapping. Let's come here, and we have a customer address. Suppose give Delhi. Let's test it. See here we are getting the delimiter. Okay, now. So whatever delimiter we want, we have to hard code it and we have to pass. Okay. So this is concatenation and read database. Now let's again come to clinch function. Let's save it. Okay. So now we have one reject function. This is also very good function. We should know this. So this reject function in the other previous classes we saw there was a reject table in the stage layer, which was basically storing the reject data during the landing to a staging. Here you
Okay.
can see.
So
Yeah.
kind of error table, right? We are.
Yeah, kind of error table in Power Center, right? So in the Power Center, we define this table by ourselves also, like due to this
Yeah,
specific
got it.
condition,
Yes.
through the router, we can route that record to error table, right?
Yes.
So same like that here, this is a inbuilt table. Here we don't have control on that. So this is a inbuilt table in the Informatica MDM. So if it will not satisfy few condition, so automatically it will route those records to reject table. Okay, now. And we have that condition, like on what conditions it can reject. So I will explain it later. Here we have those all the conditions. Okay, so in this reject table, if we are coming here, we can see that is error description. Okay, in some cases, you want this error description is given by Informatica MDM. These are system-defined error description. Okay, in some cases, you want to define user-defined error description. Then how we can achieve this? In some cases, we want that here the error description should come what we want as per our user comfort. Like a user can give the description and that description should come here. So how we can achieve this? So that we can achieve through this reject function. Okay. So here we can see in description it's given reject message text, the region to reject this record. Okay, that we have to give, and reject message value, a value of interest for the message when rejected. So this message value will be passed in the rejected description, and this output value is not used. However, it must be specified to conform to the clinch function format. This output value we have to pass in some cases. So yeah, this is about the reject function. And if we are coming to noise filters, so here noise is something like it's again a lookup concept. If you see on a high level, so noise is like suppose we have a name field and we have at the rate, we have a pipeline, we have something means other characters which are not needed in name field, and that we want.
Can you just explain about noise filter again? So just about some little bit description and what is the use of, so it's easy to grab
Yeah,
this one. Yeah.
yeah. So
And
for
where we
noise,
can use this exactly, which requirement. So
yeah, in noise function, suppose we have Ravi Kumar some places. Okay,
okay.
this is the actual name. This is actual name which is coming from source, but by customer, suppose by mistake they entered something wrong character like at the rate here and unnecessary spaces after this like that, and then they given something like suppose dot 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 something like that.
Okay.
Okay,
Okay.
so customer while entering a record customer as some a guy given a record like that, but it should be like that. This record is actually this.
Mhm.
This record should be actually this. Okay, but it came like that from the source, suppose some garbage character. Okay, so how we can clean that record? So here we can see these are kind of noise. They means we call in MDM this garbage character as a noise. Okay, so how we can remove this? So what we do, we define the kind of this is called data standardization in MDM. Okay, so what we do, what is our purpose? We have to remove this all the noises, right? Unnecessary noises. So we will create one table that will have input character and output character. Output character. Okay. In input character, we have at the rate, and we want to make what? We want to make as a just blank, right? This we have to remove it. We want to make it blank, right? Same like that, we have some dot. This dot also we want to remove and we want to make blank. So let me take this in Excel, not here. So how we can understand this? This is input char. I think examples are already here. Let me open this in detail here. Company name. LLP. Yeah, for example, here you see, if we want to remove the noise in the company kind of company related name, so here we know that this limited LLP, but here one thing has not been given. Our output for the output is given for all this null. Okay, so let me see other example. Company noise. Here is the function. See, this is the best example.
Okay.
So yeah, this is the best example. Like for name also we can use this. So name, suppose we have few at the rate we have dot that is not available. So you can add here. So suppose for at the rate you also want to make it blank. So let's keep here. Okay, so it will search at the rate and it will make blank. Apart from that, if you want to take dot also, you dot also want to make blank. Let's take dot. That is already I think there. This dot is already there. Okay, so few of the characters which you want to remove and you want to make output as a blank, or in some cases, in this noise we just remove the garbage function. But in some cases you can say that in place of making it blank, I want some a standard value. A standard value means, let me take output char. So this we understood, like if we have such kind of garbage character, we can just make output as a blank for that character. That means just we are replacing that character, and that purpose it will solve. But in some cases, like suppose we are getting some data related to United States, country name like U.S.A, and in output it should be like USA. It should be like USA. Some places we are getting United States, but the output should be always USA. Some places we are getting America, but output should be USA, because we know that this all representing the same country, right? All representing the same country, and until we will not standardize this data, we will not be able to do any reportings, or will not be able to do anything. So our system will treat this all as three record, but ideally these three are the same record. These three representing the same country. Same like that, in company name you have T.C.S TCS. Some places we have Tata Consultancy, some places you have Tata Services. And if you want to convert that all country to a single company name like TCS, so we can also achieve such kind of requirement through these clean functions. Okay.
So same like a control H function.
Yeah, same like control H. You are correct. Okay. So
Replace all.
it will find this all and it will replace all. It will find this all,
Got
it will do. So same like control H, or same like we have replace function in SQL, and we have replace function in Power Center in ETL. So same like that. It is working on the same concept. And in the Power Center, you can understand this is working same like lookup also.
Yeah.
So it will do lookup for this, and it will give output this. It will do lookup of this, it will give output this. It will do lookup of this. Okay. So all are similar. Just for understanding, we are standardizing the data. This concept we use in our ETL also, in SQL also, right? So that concept, that requirement, how we can achieve in our MDM?
Noise function.
So we can achieve through the noise function. Okay. So see, these noise functions examples are also given. Just we can add few things, or you can remove few things as per our example, and we can reuse that. So let's try to use that CL general noise function in our mapping, how we can use it. Let's come to mapping, and and let's come here function, and let's come to noise function, noise filter. Let's take general noise, and what we are going to do, we will not pass this output directly. We want to remove the noise of this output, and then we will pass the clear data, like uniform data, to the output, where we are passing. Okay, this is output basically. So this output we are passing to result. Okay. So this we have passed to the wrong input. Okay, this is search type. Let's pass the return to the input. Okay. Now let's save it, and let's change our landing data, view of the data, to make it something noise entry, so that we can clean it. Where is that CL cast full name? Okay, so in full name, suppose we had some this one. Let's pass this one, and let's see what we are getting for this. So in full name, by mistake, suppose we given like that. Okay, and in here I am giving like dot. Okay, so let's save it, and let's see. First it will as per our mapping, first it will do the lookup in the read database, and then it will fetch the full name, and once it will fetch the full name, then it will remove the noise, and then the output will be passed to our target. This is our simple logic we have. Okay, now let's save it, and let's run the job. Come to batch viewers, run the job. So we got all the record got inserted. Let's come to target table, stage table. Target table is this. So this one is working fine, very good. We have applied the pipeline, so now it's more clear. Okay, all is separated, and here we got yeah. Let's see the customer name, right? So in input we had given like we got this as a result. Let me take this result in output. Why this is not copied? Oh, sorry. Undo. So let's take this result in Excel and let's compare it. See, this all got noise got removed, right? Because in landing we had given data like that. In landing, we had data like that, CL cust full name. In the lookup table, we had data like that. And see, this all data got cleansed properly. We have data like that, and this Ravi Kumar is coming clearly like that, right? So we can see now our cleanse function is working, and it is removing the extra unwanted character, and it is removing the noises. Like that, you can create a cleanse function, noise function here. You can add your all the noise characters, whatever you want to remove, and in output, what you want to replace that noise character, you can also specify. Like for that, if you want to change it, just you can come here, and in output, whatever you want, you can change it. Okay, so accordingly, it will just replace that character. And after doing this configuration, you can review that cleanse function in the mapping section. So this is all about noise filter. This was important. We will get such kind of filter at more places, that is called geography. Here, if you come, so in geography, what it is doing, if I am coming to cities, to see. So what it is doing, it is searching that particular city, and it is standardizing that. Like Toronto or TO, it is still Toronto. Same example which I given for USA. Okay, this is for country. So this is for cities, and here in country also we can see some example. Like for USAC, USA we want to make United States. US or you want to make United States. America you want to make United States. This also you want to make United States, right? So in input we have this four data, but it is in output it is standardizing to this data. So this output you can give USA, United States, like that, whatever you want as per your requirement. Okay, in output we can specify any value. Just we can change it, and we can give any value. So like that we can standardize this data with the help of this geography and noise conditions.
Okay.
So difference between these two is that this section is basically to remove the noises. Okay, noise we understand is unwanted data, right? So this section is for removing the noise, and this section is for geography. So in geography, we will have data for country, we have city, we have a street, we have a states here. So a state same like Colorado, and CO is same as that, right? So like we write some places Delhi, some places DH, some places DLH, something like that, right? So we can standardize those data in the street section or state sections. And apart from that, if you want to create your own function, you can also create your own function.
Yeah,
Okay.
that's why my next question.
Yeah.
Yeah. Okay. Can
So
we can customize the function.
Yeah, you can completely customize. So these are the examples given by Informatica. This we have not created. So for our understanding, they have given some examples so that we can take some few examples and we can understand that. Apart from that, if you want to create some new geography function as per your need, like for district or for police station or for kind of something else, you can create as per our requirement, and you can give the details accordingly, like that. And here what it is doing the nesting. So it is same like if you know the maplet concept in Informatica Power Center. Maplet what does? It will create a transformation, and that transformation you can use within the transformation. Okay, so you can create one mapping, and that mapping it will have input and output port. Okay, and that mapping again you can reuse within the mapping as a transformation. That is called maplet. So for understanding that, I can take other example. We understand the function call, right? Function in a SQL or in Java or in C, every places. So we create some function. Suppose there is a function which is taking the details of the what do you say, a state, and it is giving its name of the country, a state detail, how many district it have. It is giving the details of the state. It is taking the input of the state name, and it is giving all these details. So that function we can create in our Power Center also, in SQL also, in Java also, and same kind of thing we can do here also. So what we can do, whatever function we have created for cleansing the noise, we can review that function in between that function also. So here we are trying to create one function, one cleanse function, and within that clean function we want to use the other function. That also we can do. So here it will just take the input, it will remove the noise. Accordingly, whatever value we are giving, again it will pass that value to the cities, and it will go to CT clinch function. It will standardize the CT value, and then it will pass to the output. And that entire thing you can use as a function. So in this entire thing, you have to pass one input, and it will give output like that. So this output you can use anywhere. Okay. So on high level, it's a nesting of the functions, function within the function. That you can do here also. This option is available. So on high level, this geography and noise filter is same. This is just removing the noise, and this is just standardizing the geography related data. Okay.
Okay.
So now if we are coming to logic function, so this is very simple. Logic I should not cover because this is very simple. AND function, OR function, NOT function, is a string null, right? These are very simple.
Operator like a
Yeah, you are correct. Same like a SQL operator, right? So if we have a 3 AND condition, so this all this should be true, no? If we have 3 OR, then any one of this is true. So this is very simple. I will not cover this. You can just read and you can understand. So
okay.
I should not focus on that. Let's come to math function. This is also very similar to our SQL function. So in math, we have addition of integer, division, ceiling, floor. What is the floating point number to convert?
Data type.
Data type, just yeah. So this is also a simple math function of the SQL. Let me come to companies. What we had here, company don't have any here. Data conversion. So this is data casting. Okay.
Okay.
So data casting we do in all the languages. In Power Center, we get input as a character, and sometimes we need to nest it we are getting 1, 2, 3 in the varchar, and we have to make it to integer. So we have to do such casting in Power Center, in SQL also, right? So same kind of thing we can do here also. So data casting is available here. We can make a integer, we can make date, we can make float, something like that. So data conversion we have. In general processing, we don't have. So we have these means the limited functions available in this MDM, and these all function we can use here as per our need. Okay, in the mapping section. And apart from use of this clinch function in the mapping, we will see that this clinch function can be used at more places. The scope of this clinch function is not here only. Okay, that this clinch function is can be only used in the mapping. The scope is not till here. The scope is very high. We will see that once we will learn the SIF Services Integration Framework in the Java, how we can use the inbuilt API of this Informatica MDM, and how we can use the Eclipse and SOAP UI client tool to play with these tables and to play with the functionality of Informatica MDM. So there also we will use these clinch functions. And once we will learn the entity 360 provisioning tool, there we will also use these clinch functions. Once we learn the IDD Informatica data director, there also we will use these clinch functions. Okay. So the clinch functions scope is very high. We will see at many places. At first place, we have seen that in mapping how we can use and how it can behave. So behavior we have learned, that was more important, like how what will be input and what will be output. That we have learned, that was important. And the use we will see the many places in future. Okay.
Okay.
So this is all about today class. Let me stop the recording so that we will have question and answer.